and thanks for your look and watch our videos. This video is our part 3 about EE542 final project about clustering cancer type based on gene express. Actually, before that, we have already tried Gene Express, mRNA Express, and download all this data from GNC. But finally, we found that because all those features have, because all of them have different dimensions, so make the things easier, so we can hardly to process it. So we just use mRNA data to let these things clear, and then here we just try to cluster these three diseases, that is breast, kidney, and lung, because we need to shrink our scope and can get and probably can get the detailed and special and specific result. So we shrink our space and try to get the exact result. Okay, so through this extract, and finally we got totally over 3,000 records, and here just these 3 diseases and normal case we maintained. Then at this part, we have already moved our development from local to AWS. We use the Databricks just like I mentioned before, and we develop it on Spark. And you can see that based on the last progress, this time we, because our data site just over 3,000, so we have to reduce our dimension to guarantee we have not overfit. So we need first to analyze which feature is important, and in order to analyze this, we use the 2 methods. The first method, we use Pearson covariance to analyze it. Here I have write a UDF function to count each factor's Carson similarity, and then we just try to maintain the. So if some features have a higher similarity, we'll drop the one of them. And the second method, we use the random forest, because from random forest method we can get feature importance. So just analyze feature importance, we also can get which feature maybe have a major position, maybe have a major effect, and some other features if his effect is so slow, and we also can drop it. So here is our procedure, and I've already run it on this Databricks platform. And here, and his part is about we use the random forest. Okay, this is we got accuracy. It's about 80%. And next, and about feature importance, and because in Spark there have still no feature importance like Python, so we have to we are continue to try to implement it. That is still not work now, so we have to continue to focus on that. But here you can see I will just try them on local because it does not work, so I don't want to try online because of some payment. And here you can see that I try to get feature importance, but there have some problem because our dataset type have some problem. So I just trying to fix it. And the last part, we use when we get features we want to get. What is important, and then next we just use k-mean to cluster our data. And you can see that in this part we have already first to transfer our data set from multiple column to one column is a vector, to one column a vector, just name the features, and then transfer them, and then we can use k-mean to fit it. Now I'm not sure why I can run it normally on my local, but on this on AWS maybe it is some wrong problem, so I'll continue to fix it, but I can show on my local result. Yeah, here we first transfer multiple columns to one vector column, and then to try to cluster them, use all of data. And you can see this is an k here I set 4 because we just select 3 cancer type and plus 1 normal cases. So I set it k equal to 4. And you can see after k-mean clustering, we get cluster center. Because our dimension is much more than 1, 2, so we cannot virtualize that because it's higher dimensions. So for get the visualization, I try to just select any 2 dimensions of multiple features and give some sensor knowledge. So I select any of them and try to plot it. And from this picture you can see actually this you can see maybe because I just selected the first feature and the second feature, so these 2 features have a higher similarity. I tested this similarity is about 0.999, so we actually cannot cluster them clearly. Yeah, and so if we select the lower similarity, maybe the diagram will be clear. But actually we cannot show them just because this is a higher dimensional cluster. So we hardly to show it in 2 dimension. So in order to resolve this problem, and next we'll plan to use PCA to decrease our dimension to 2 dimension, and try to evaluate our cluster is good or not. So hopefully it works. Thanks for your attention. Thanksgiving Day. Happy Thanksgiving Day. See you.